Hello everyone. Today we will be doing the experiment on Wittig reaction, and these are the reaction materials that we will need. The yelid that will be prepared today in the lab is synthesized using a commercial Wittig reagent. The name of the reagent is benzyl triphenyl phosphonium chloride. Yes, that is a mouthful, but I think we need to use this throughout our experiment, and we are weighing this out at this point. So we will need around 0.48 grams of that. Then we transfer the benzyl triphenyl phosphonium chloride into a 5 ml reaction vial containing a spin vane. Then, using a measuring cylinder and with the help of a Pasteur pipette, we will measure out 2 ml of absolute ethanol from the reagent bottle. This 2 ml of absolute ethanol will be transferred into the reaction vial. Cap the reagent bottle after you are done. Stir the mixture to dissolve. Note that the heat is turned off. Once all the solute dissolves, we are going to add 0.75 ml of sodium ethoxide into the mixture using a mechanical pipette. Slowly add the sodium ethoxide, cap the reaction vial immediately, and then keep it in this state for 15 minutes. Notice the change in color. Next, we are going to add 0.15 ml of cinnamaldehyde and 0.5 ml of absolute ethanol in a clean and dry new reaction vial. So that's the 0.15 ml of cinnamaldehyde. Remember to cap the reagent bottle. Then, using the same mechanical pipette, we are going to pipette out 0.5 ml of ethanol. Pipette out 0.5 ml of absolute ethanol from the reagent bottle to the reaction vial. Cap the vial as soon as possible. Place the vial into the aluminum block on the magnetic stirrer. After about 10 minutes or so, we transfer the cinnamaldehyde ethanolic mixture from the second reaction vial to the first reaction vial. The exact time that elapses needs to be checked.
Note that the magnetic stirrer is still on while the transfer is taking place.
Notice the change in color of the reaction mixture in the first vial as the cinnamaldehyde is added now and as the reaction progresses.
We leave this to react for about 10 minutes or so. After stirring for 10 minutes, we transfer the reaction vial into an ice bath directly to cool down. The reaction vial will be left in the ice bath for 10 minutes to cool. After cooling for 10 minutes, we will take out the reaction vial from the ice bath and then we will vacuum filter the reaction mixture. Turn on the vacuum, pour the reaction mixture into the harsh funnel, and then
The filter flask, as in where the liquid or the filtrate, as we name it, is being collected, must be clean as we are going to collect both the powder that is on the harsh funnel as well as the liquid. One of the isomers, cis or trans, will be present in the filtrate.
and rinse the spin vane and the insides of the reaction vial with ice cold absolute ethanol in order to get as much yield as possible. We will also rinse the product with ice cold ethanol. After the product has been subjected to vacuum drying for about 2 or 3 minutes, we are going to switch off the vacuum and then we are going to collect the solid as well as the filtrate in 2 different beakers. This is in contrast to our previous experiments in which we only collected the solid. After transferring into a beaker, we add 3 ml of DI water and kind of crumble the solid and get it in contact with the solvent as much as possible in order to remove the salt, sodium chloride. We also collect the filtrate to a separate beaker. Then we subject the washed crude product to another round of vacuum filtration in order to retrieve the product without sodium chloride. This is what the product looks like after the second round of filtration. We will be transferring the product to a vial. The product is then carefully scooped up from the harsh funnel and then carefully transferred into a pre-weighed labeled product vial.
Then we are going to use the sample to carry out TLC or thin layer chromatography for short. TLC must be carried out quickly as the cis-trans alkene isomer in the filtrate will photochemically convert to trans-trans isomer if it sits out for too long.
So thin layer chromatography or TLC for short is a separation technique
that is very often used in organic chemistry experiments, and something that we learned in a previous organic course. For those of you for whom the concept is new, I'm just going to go over the basic details. So it is a chromatographic technique, which is pretty simple, and it is used to separate non-volatile mixtures, and it is performed on a sheet of absorbent material. In our case, the absorbent material is silica or SiO2, which is quite polar. And this silica will be referred to as stationary phase. And then there is a solvent, which is mobile phase, that is drawn up the plate by a capillary action. The mobile phase has a different polarity from the stationary phase. So in this case, the stationary phase is pretty polar and the mobile phase is less polar. We draw a baseline 1 centimeter from the bottom of the plate, and the baseline is the line where we apply the spots. And then after we place the plate inside the jar, the mobile phase moves up the plate and we run, and then we let this go on until the solvent level reaches 1 centimeter from the top of the plate, and we call it solvent font. So at that point we take the plate out of the jar and we mark the solvent font. The spots containing the samples that we have run are visualized under the UV light, and to quantify the results we obtain the RF value, or the retardation factor. In general, a substance whose structure resembles the stationary phase will have low RF value. So in this case, the stationary phase is the polar SiO2. So the polar molecule will have the lower RF value, while the one that has a similar polarity to the mobile phase, so the less polar molecule, will have a higher RF value. So the RF values are characteristic of that specific substance, but it will change depending on the mobile phase and the stationary phase that is used. I have linked the Khan Academy video that is available on the internet for free for learning this technique, and I have kind of just googled TLC Khan Academy and got this link. So I believe that this will be very helpful, and it's only a 5-minute video. So we draw the baseline, the line that is drawn, that is 1 centimeter from the bottom of the plate, which is parallel to the bottom of the plate. And the baseline is the line on which the samples will be applied for separation. And I have also marked one spot where I will be putting the filtrate, marked with an F, and the other spot where I will be putting the product, marked with a P. After loading the sample on the TLC plate by using the capillary tube to spot the samples, we transfer the plate into the jar containing our mobile phase. In this case, it is Ligroin. Then we wait for the mobile phase to be drawn up the plate by capillary action, and we stop the TLC right when the mobile phase is about 1 centimeter from the top of the plate. When the mobile phase reaches within 1 centimeter from the top of the plate, we take out the plate from the jar. Then quickly and carefully we mark the solvent font before it evaporates. The solvent font is the maximum distance the solvent has traveled. After taking it out of the jar, we have to expose the TLC plate to UV light. At first, we expose it under short wave, and then we mark the circles where we see the spots. And we also mark the solvent font under the UV lamp.
That was the TLC plate under shortwave IR. Then we changed it to long wavelength, which is kind of violet bluish. As you can see, there is not much visuals under the long wave. Now the next thing we'll do is to measure the distance the spots have traveled, and this will be used to calculate the RF value. For the spots, we do this by measuring the distance from the baseline to the middle of the spot. And for the solvent font, we do this by measuring the distance from the baseline to the solvent font. We did this using a ruler, and as you can see, for the filtrate, one of the spots traveled 2.6 centimeter and the other spot traveled 3.3 centimeter. So there are two spots. And for the product, there is only one spot and it's traveled 2.5 centimeter. The solvent font traveled 7.8 centimeter in total.
Our next characterization is to take the melting point. As we have seen before, we are going to take the sample in a little bit of the sample in a melting point tube, which is closed in one end, and then we drop the melting point tube through a rod a few times until the sample, all of the sample collects at the bottom, and then we insert the melting point tube inside the instrument. So when we insert this tube inside the melting point instrument, the temperature of the melting point instrument, when turned on, it is at about 20 degrees Celsius. And then we are going to make the temperature rise slowly. And we can also set the pace at which the temperature rises. Since we, as in the person, whoever is doing the experiment, has a rough idea of the temperature at which the sample is supposed to melt, we are going to at first run it very fast. And then when the temperature of the instrument is close to the melting point of the sample, the literature melting point, we are going to um, we are going to slow down the pace at which the temperature rises. As we have seen before, the sample melts over a range of temperature, and we need to record the whole range.
So that was it, guys. We have done the Wittig reaction and then we have collected our product and we have taken the readings for the mass of the product and we ran the TLC and we took the melting point of the product, the range of the melting point. And we don't need to take the IR for this reaction. And that's it. So that was the Wittig product synthesis and Wittig product characterization done.
So before you guys leave, as I have said before, the bench top and the station at which we work should all be cleaned and everything should be put away. The pot plate, all the glassware that you work with should be cleaned with acetone, first with water and then with acetone. And all the liquid waste goes to liquid waste. And if you have any solid waste, it goes to solid waste. If you have a stir bar or anything like that, that should also be cleaned with that water and with acetone. And then it should be put away. And if you guys have a broken glass waste, even the melting point tube should goes to the broken glass waste. And yeah, everything should be clean and put away, and you should get your notebook signed by the TA.
So thank you. See you next time.